So now we discuss about the exercise 7.5. So now we discuss about the examples of 7.5. So indeterminate forms. Now we discuss about the indeterminate form. Indeterminate form means 0 by 0, infinity by infinity. These are the indeterminate. Indeterminate means it is not answer. So no answer. So 0 by 0 we can't define. Infinity by infinity we can't define. So next L'Hopital rule. So L'Hopital rule means it is a limit extends to a f of x by g of x. This is a L'Hopital rule. So next L'Hopital rule means limit extends to a f of x by g of x. So that means limit extends to a f of x equal to limit extends to a g of x equal to 0. The next step, limit extends to a f of x by g of x equal to limit extends to a f dash of x by g dash of x. So next limit extends to a f of x equal to limit extends to a g of x equal to plus or minus infinity. So limit extends to a f of x by g of x equal to limit extends to a f dash of x by g dash of x. So here we discuss about, first of all I define the indeterminate form. Indeterminate form means that means the numerator 0 by 0. This is no answer for this. So this form it is indeterminate, 0 by 0, infinity by infinity. We call this is the indeterminate. Indeterminate, this is not answer. We can't further proceed. We can't define. So this is the indeterminate form. So this, after this format we apply the L'Hopital rule. So limit extends to a f of x by g of x. So next we discuss about the example 7.33. Evaluate limit extends to 1 x square minus 3x plus 2 plus by x square minus 4x plus 3. So now, so first step I write the given functions. So limit extends to 1 x square minus 3x plus 2 by x square, here the minus will come. So x square minus 4x plus 3. So next step I substitute, put x equal to 1. So throughout the equation I substitute x equal to 1. So I write x square minus 3x plus 2 by x square plus minus 4x plus 3. So I substitute x equal to 1 means 1 square minus 3 into 1 plus 2. In the numerator I substitute x equal to 1. So 1 square I write it here, minus 3x means 3 into 1 I write here. Next plus 2 I write here, by now I substitute x equal to 1 in the denominator. So x square means 1 square plus next 4x. 4x means 4 into 1 plus 3. So equal to 1 minus 3 plus 2 by 1 minus 4, here minus will come. So 1 square minus 4 into 1 plus 3, here minus sign. So 1 minus 4 plus 3. So in the next step, in the numerator we add the numbers, 1 plus 2 3, 3 minus 3 0, by 1 plus 3 4, 4 minus 4 0. So you see 0 by 0 is the indeterminate form. Indeterminate form means it is no answer. This is not answer. So this is the indeterminate form. So after this indeterminate form we apply the L'Hopital rule. So L'Hopital rule means just we differentiate the numerator and denominator. So I write the functions, what the given function I write that function. So limit extends to 1 x square minus 3x plus 2 by x square minus 4x plus 3 equal to limit extends to 1. Now I differentiate the numerator. I differentiate the x square. So differentiation of x square is 2x. I write it minus 3 into differentiation of x is 1. So minus 3. Differentiation of 2 is 0 because constant is 0. Differentiation of constant is 0. So differentiation of 2 is 0 by, now I differentiate the denominator. So differentiation of x square is 2x minus 4 into differentiation of x is 1. So minus 4 equal to, now I substitute limit extends to 1 means I substitute x equal to 1. So throughout the equation I substitute x equal to 1. So 2 into 1 minus 3 by 2 into 1 minus 4. So 2 minus 3 means minus 1. 2 minus 4 is minus 2. So minus cancelled, 1 by 2. So 1 by 2, this is the answer for limit extends to 1 x square minus 3x plus 2 by x square minus 4x plus 3. So we find the answer. Next Second, example 7.34, compute the limit x tends to a x power n minus a power n by x minus a. So compute the limit. Now we find out the answer for this equation, this limit. So I write the given limit. So given function is limit x tends to a x power n minus a power n by x minus a. So here x tends to a will come. Limit x tends to here a, not infinity. So limit x tends to a x power n minus a power n by x minus a. Now I substitute x equal to, that means x equal to a. So here a will come. So put x equal to a. So a means here a power n minus a power n, substitute x equal to a minus a. So a power n minus a power n is 0 by a minus a is 0. 0 by 0 is indeterminate form. Indeterminate form is no answer for this. We can't define. So after the indeterminate form, we apply the L'Hopital rule. So therefore applying L'Hopital rule, therefore I write the given function. This is the given function. I write here limit x tends to a x power n minus a power n by x minus a. The next limit x tends to a. Now I differentiate the numerator and the denominator. Separately I differentiate the numerator, denominator. So first I differentiate the numerator. So differentiation of x power n is n into x power n minus 1. Differentiation of a is a constant, so it is 0. So n into x power n minus 1 by differentiation of now I differentiate the denominator. Differentiation of x is 1 and the differentiation of constant is 0. So n into x power n minus 1 by 1. So limit x tends to a n into x power n minus 1. So in the next step, here the limit is x tends to a. So I substitute x equal to a. So here I substitute x equal to a means n into a power n minus 1. This is the answer for this limit. Therefore limit x tends to a x power n minus a power n by x minus a equal to n into a power n minus 1. This is answer. So next example 7.35, evaluate the limit x tends to 0 sin mx by x. So limit x tends to 0 sin mx by x means you substitute x equal to 0. So sin 0 by 0, sin 0 is 0, 0 by 0. So applying L'Hopital rule. So L'Hopital rule, after the this is the indeterminate form. So after the here equal to will come. That means sin mx by limit x tends to 0 sin mx by x equal to, we apply the x equal to 0 here. So sin 0 0. So and the denominator 0. So equal to 0 by 0. 0 by 0 is the, that means indeterminate form. So after the indeterminate form, we apply the L'Hopital rule. So in the next step I write it applying L'Hopital rule. So therefore limit x tends to 0 sin, here mx will come, sin mx by x. Here no n, m, sin mx by x. Therefore now I differentiate the numerator and denominator separately. So first I differentiate the numerator. So differentiation of sin mx is cos mx. Next I differentiate the mx. Differentiation of mx is m into differentiation of x is 1. So cos mx into m by differentiation of x is 1. So therefore limit x tends to 0 cos mx into m. Now the limit x tends to 0. So I substitute x equal to 0. So cos 0 into m. Cos 0 is 1. 1 into m. Therefore limit x tends to 0 sin mx by m equal to m. This is the answer for this function. That means this limit. Therefore limit x tends to 0 sin mx by x equal to m. Example 7.36, evaluate the limit x tends to 0 sin x by x square. So now limit x, now I write the limit, the function, that means limit x tends to 0 sin x by x square. So I apply x equal to 0. So x equal to 0 means sin 0 is 0, 0 by 0, 0 by 0 is the indeterminate form. So after the indeterminate form, we apply the L'Hopital rule. Therefore applying L'Hopital rule is limit x tends to 0 plus, this is the right limit. I apply the right limit. X tends to 0 plus, that means right limit. So sin x by x square. So limit x tends to 0. I differentiate the numerator. Sin x, differentiation of sin x is cos x by differentiation of x square. Now I differentiate the denominator. So differentiation of x square is 2x. Therefore now I substitute the 0. So x equal to 0. So cos 0 by 0. 1 by 0 is there is a 0 in the denominator. The value is infinity because 1 by 0 is infinity. So next also put x equal to 0. Here I substitute x equal to 0. We get the answer infinity. Next I calculate the right limit. So limit x tends to 0 minus. 0 minus means we take the left limit. This is 0 plus means right limit. 0 minus means left limit. So limit x tends to 0, that means sin x by x square equal to limit x tends to 0, and that means the differentiation of sin x is cos x. Cos x by differentiation of x square is 2x equal to, so now I substitute cos 0 by 2 into 0. Cos 0 is 1. 1 by 0, that means here left limit it depends on the minus infinity. So therefore 1 by 0 is the infinity, though, so we take the left infinity. Left limit means minus infinity. It represented by minus infinity. Right limit means represented by plus infinity. So 1 by 0 is infinity. So right limit in plus left limit minus infinity. Therefore the left limit and the right limit are not same. The limit does not exist. So from this we tell that the left limit, right limit not same. So we conclude that the limit does not exist. Now example 7.37. So you see the question, if limit theta tends to 0, 1 minus cos m theta by 1 minus cos n theta. Here the question is, this is the numerator cos m theta, no n. So 1 minus cos m theta by 1 minus cos n theta equal to 1. Then prove that m equal to plus or minus n. Now we will prove m equal to plus or minus n. So we find out the, from this we will prove m equal to plus or minus n. So first I write the given limit. So limit theta tends to 0, 1 minus cos m theta by 1 minus cos n theta. So 1 minus, now I substitute the theta value. Here theta tends to 0 means you substitute theta equal to 0. So this equation I substitute theta equal to 0. 1 minus cos 0 by 1 minus cos 0. Cos 0 is 1. 1 minus 1 by 1 minus 1, 0 by 0. 0 by 0 means it is a indeterminate form. Indeterminate form means no answer for this. We can't define this. So after this indeterminate form, we apply the L'Hopital rule. So therefore applying L'Hopital rule, therefore I write the given limit. The given limit is limit theta tends to 0, 1 minus cos, here m, cos m theta by 1 minus cos n theta equal to limit theta tends to 0. Now L'Hopital rule means we differentiate the numerator and denominator separately. So first I differentiate the numerator. So 1 minus cos m theta, differentiation of 1 is 0, minus differentiation of cos is minus sin theta. So already there is a minus of minus sin m theta is plus sin, so I write it minus of minus sin m theta. Next I differentiate the m theta. Differentiation of m theta is m by, next I differentiate the denominator. Differentiation of 1 is constant, so its answer is 0. So 0 minus differentiation of cos n theta is minus sin n theta. Differentiation of n theta is n. So the next step, minus into minus plus. So m into sin m theta minus into minus plus n into sin n theta. Therefore limit theta tends to 0, m sin m theta by n sin n theta. So from this equal to limit theta tends to 0, m, that means m by n sin m theta. Now I write this function as sin m theta by theta, that means I take multiply and divide by theta. Theta by theta means I write it, that means I write sin m theta by theta by sin n theta by theta. Theta cancelled, again we get this equation, same equation. So I write it sin m theta by theta, sin n theta by theta. This answer is m square, that means m. Sin m theta by theta is m, sin n theta by theta is n. Here sin n theta by theta. So its value is sin m theta by theta value is m, sin n theta by theta value is n. So the answer is, that means here I taken that means So I write m by n into its numerator value is m, denominator value is n. So m square by n square. This step directly we come from we using the example 7.35. Example 7.35 is limit x tends to 0 sin mx by x. Its answer is m. So here the same result we used here, sin m theta by theta, its value is m. Sin n theta by theta, its value is n. So m by n, already there is a m by n, so we multiply m square by n square. Therefore limit theta tends to 0, 1 minus cos m theta by 1 minus cos n theta equal to m square by n square. This is the answer. So next so we find the limit answer. The limit answer is m square by n square. You see the question, that question is limit theta tends to 0, 1 minus cos m theta by 1 minus cos n theta equal to 1. So I write it, the given limit, given result, limit theta tends to 0, 1 minus cos m theta by 1 minus cos n theta equal to 1. After I substitute this limit answer, this limit answer is m square by n square. Now you see m square by n square equal to 1. Now I just doing the cross multiplication. So n square into 1, n square. So m square equal to n square. Now I eliminate the powers. So this square I write in the RHS means it is a square root. So m equal to plus or minus square, that means square root of n square. This square I write in the square root. So m equal to square root of n square means square root and square cancelled. So plus or minus n. So m equal to plus or minus n. This result only. So this result is we proved. This is the required result for our problems. So we proved this result. Next example 7.38. Now we will discuss about the example 7.38. Evaluate limit x tends to 1 log of 1 minus x by cot of pi x. Evaluate means we find out the answer for this limit. So I write the given limit, limit x tends to 1 log of 1 minus x by cot pi x. So next step I substitute, put x equal to 1 because the limit x tends to 1 means x equal to 1. So I substitute this equation, log of 1 minus 1 by cot pi into x is 1. So pi into 1. So log 0 by cot pi. So log 0 is minus infinity, cot pi is infinity. So minus infinity is also we write in the plus infinity. So infinity by infinity, again it is an indeterminate form. Indeterminate form means it is no answer for this. We cannot find out the answer for this. So we stop up to this. After that, so after the indeterminate form, we apply the L'Hopital rule. Therefore, applying L'Hopital rule, therefore I write the given limit, limit x tends to 1 log of 1 minus x by cot pi x. Now limit x tend to 1. So now I differentiate the numerator, log of 1 minus x. I differentiate the log. Differentiation of log is 1 by 1 minus x. Next I differentiation the 1 minus x. Differentiation of 1 minus x is, differentiation of 1 is 0 and minus x is minus 1. I write it here. Next by denominator, now I differentiate the cot. Differentiation of cot is minus cosecant square pi x. Next I differentiate the pi x. Differentiation of pi x is pi. So next limit x tends to 1. So minus this, I multiply both the factor in the numerator. So minus 1 by 1 minus x by minus this pi, I write minus pi cosecant square pi x. So next step, minus minus cancelled. So in the next step, limit x tends to 1, 1 by 1 minus x by pi into cosecant square pi x. So limit x tends to 1, 1 by 1 minus x by pi into cosecant square, I write it 1 by sine square pi x. So cosecant means, cosecant is the reciprocal of the sine, sine is the reciprocal of the cosecant, so it is the reciprocal to each other. So I write it cosecant as 1 by sine, so 1 by sine square pi x. So therefore limit x tends to 1, 1 by 1 minus x by pi by sine square pi x. Again I substitute, the limit is x tends to 1, so I substitute x equal to 1. So 1 by 1 minus 1 by pi, this is the numerator is 1 by 1 minus 1, I substitute here, by denominator is pi into 1 by sine square pi x equal to 1, so sine square pi. So in the next step, 1 minus 1 is 0, 1 by 0, 1 by 0 by pi into 1 by 0. 1 by 0 is infinity, so infinity, numerator value is infinity, denominator value is also infinity, so infinity by infinity. Again we get the indeterminate form. So when we get the indeterminate form, after that we apply the L'Hopital rule. So second time we get the indeterminate form, so we apply the L'Hopital rule. So next here you see limit x tends to 1. This is the function 1 by 1 minus x by pi into sine square pi x. Now I differentiate, that means I write it this function's limit, that means x tends to 1 by 1 minus x into, I reciprocal this function, so because it is in the denominator, so sine square pi x by pi. So in the next step, limit x tends to 1 sine square pi x by pi into 1 minus x. So I converted into numerator by denominator. So now, so its value is I apply the limit, I got the answer indeterminate. So after the indeterminate we apply the L'Hopital rule. So I applying L'Hopital rule. So L'Hopital rule means we differentiate the numerator and the denominator. So limit x tends to 1, differentiation of numerator is differentiation of sine square pi x, so 2 into sine pi x, differentiation of, and next so differentiation of sin x is cos pi x, differentiation of pi x is pi by, next pi is a constant, so pi, differentiation of 1 is 0, differentiation of minus x is minus 1, so minus 1 means minus pi into minus 1 minus pi. The next step here, pi cancelled, so I write, that means we apply the limit, so therefore here limit not come. Yes, limit will come here, that means limit x tends to 1 2 sine pi x cos pi x pi by minus pi. After that we apply the x equal to 1, so x equal to 1 means we just substitute 2 into sine pi cos pi, so x equal to 1, so 2 sine pi cos pi, sine pi is 0, cos pi is minus 1, so minus 2 0 into minus 1, so the answer is 0. Therefore we apply the L'Hopital rule, this answer is 0. This is the answer for the our given limit. So you see, now we discuss about the example 7.39. Evaluate limit x tends to 0 plus 1 by x minus 1 by e power x minus 1. So now I write the given limit, limit x tends to 0 plus 1 by x minus 1 by e power x minus 1 equal to, x tends to 0 plus means I substitute the x equal to 0, so I substitute x equal to 0 means 1 by 0 minus 1 by e power 0 minus 1, 1 by 0 is infinity minus e power 0 is 1, so 1 by 1 minus 1, 1 minus 1 is again 0, 1 by 0 1 by 0, 1 by 0 value is infinity, so infinity minus infinity, this is the indeterminate form, we can't define this answer, there is no answer for this format. So after the indeterminate form we applying L'Hopital rule. So I write the given function, given limit x tends to 0 plus 1 by x minus 1 by e power x minus 1 equal to limit x tends to 0 plus, now I just doing the cross multiplications, so 1 into e power x minus 1 is, that means e power x minus 1 minus x into 1 is x, so e power x minus 1 minus x by, and the denominator we multiply x into e power x minus 1. So now I applying L'Hopital rule. Therefore limit x tends to 0 plus, so I write that L'Hopital rule means we differentiate the numerator and denominator. First I differentiate the numerator, differentiation of e power x is e power x, differentiation of 1 is their constant, so its value is 0. So next differentiation of x minus, I put the minus sign, differentiation of x is 1 by, next here you see there is a 2 function x and e power x minus 1, there is a 2 function, so we apply the UV method, u into dv plus b into du. So therefore I write the x, I differentiate the second function e power x, differentiation of e power x is e power x plus, and differentiation of minus 1 is 0, so next plus again e power x minus 1, differentiation of x is 1, so I write it limit x tends to 0 plus e power x minus 1 by x e power x plus e power x minus 1. So the next step, e power 0 minus 1 by, now I substitute here x tends to 0 plus, I substitute x equal to 0, so e power 0 minus 1 by 0 into e power 0 plus e power 0 minus 1, so therefore e power 0 is 1, 1 minus 1 by 0 into 1 is 0 plus 1 minus 1. So 1 minus 1 by denominator is also 1 minus 1. 1 minus 1 is 0 by 0. This answer is 0 by 0. So 0 by 0 is indeterminate form. So again I apply the L'Hopital rule. So I write the here I write this functions limit. I not write the given functions. I write this after the differentiation. I write it. This is the after the differentiation. So limit x tends to 0 plus e power x minus 1 by x e power x plus e power x minus 1. So again I applying L'Hopital. L'Hopital rule means I differentiate the numerator and the denominator. So you see, limit x tends to 0 plus e power x by, now I differentiate the numerator. So differentiation of numerator is e power x. Next differentiation of denominator is x e power x. There is a two functions, so I write it. First I write the x, differentiation of e power x plus I write the e power x, and the differentiation of x is 1. So next differentiation of 1 is 0. So x e power x plus e power x plus e power x equal to limit x tends to 0 plus e power x by x e power x. E power x plus e power x is 2 e power x. Therefore e power x by x e power x plus 2 e power x. In the next step, now I apply the limit x equal to 0. So e power 0 by 0 e power 0 plus 2 e power 0. That means e power 0 is 1. 1 by 0 into 1 plus 2 into 1. So 1 by 2. Therefore this is the answer for the given limit. Therefore the given limit is limit x tends to 0 plus 1 by x minus 1 by e power x minus 1 equal to 1 by 2. This is the answer. So next example 7.4040 evaluate limit x tends to 0 plus x log x. So now we find out the value for this. Evaluate means we find out the value. Limit x tends to 0 plus x log x. So now I write the given limit. Limit x tends to 0 plus x log x equal to limit x tends to 0 plus. Now I write this function as log x by 1 by x. Numerator by denominator I write it. Now I substitute the values. X tends to 0 plus means that is the right limit. It represent the right limit. So I substitute x equal to 0. So log 0 by x is 0. So log 0, 1 by 0 is infinity. Log 0 is minus infinity. Minus infinity means infinity. So our answer is infinity by infinity. So infinity by infinity is indeterminate form. So indeterminate form means there is no answer. So we apply the L'Hopital rule. This is an indeterminate form. So applying L'Hopital rule. So L'Hopital rule means now I write the given limit. This is a given limit. Limit x tends to 0 plus log x by 1 by x. That means here now applying the, that means here the function is x log x. So I write it. That means log x by 1 by x. This is our given limit. So applying L'Hopital rule. L'Hopital rule means first I differentiate the numerator and the denominator. So differentiation of numerator is log x is 1 by x by differentiation of denominator is minus 1 by x square. So limit x tends to 0 plus we write it 1 by x into minus 1 by x square is x square minus 1. So x cancelled. So x by minus 1, 0 by minus 1 is 0. So therefore our answer is 0. So this is the value for our given limit. That means limit x tends to 0, x log x equal to 0. This is the answer for our given limit. Next we discuss about the example 7.41. 7.41 evaluate limit x tends to infinity x square plus 17x plus 29 by x power 4. So again they evaluate means we find out the answer for this limit. So I write the given limit. Limit x tends to infinity x square plus 17x plus 29 by x power 4 equal to, I substitute the x tends to infinity means I substitute x equal to infinity. So put x equal to infinity. So throughout the equation I substitute infinity. So infinity square plus 17 into infinity plus 29 by infinity power 4. So infinity square we multiply infinity means again we get the answer infinity. Addition, subtractions and multiplication of the infinity is infinity by infinity power 4 is infinity. So this is the indeterminate form. So indeterminate form, so we apply the L'Hopital rule. So I write the given, again I write the given limit. This is the given limit. Limit x tends to infinity, x square plus 17x plus 29 by x power 4, applying L'Hopital rule. So L'Hopital rule means differentiate the numerator and denominator. Now I differentiate the numerator. Limit x tends to infinity, differentiation of x square is 2x plus differentiation of 17x, 17 into differentiation of x is 1, so 2x plus 17 by differentiation of x power 4 is 4x cube. So therefore again I apply the limit value. X tends to infinity means x equal to infinity. Also put x equal to infinity. So I substitute x equal to infinity means 2 into infinity. So infinity plus 17 is, that means we multiply the any numbers with infinity, we get the answer infinity. We add the any number with infinity, we get the answer infinity. So 2 into infinity is infinity, infinity plus 17 is infinity. So the numerator value is infinity by 4 into infinity power 3. Infinity power 3 is infinity, 4 into infinity, infinity. So our answer is infinity by infinity. So infinity by infinity is indeterminate form, no answer. This is not answer for our, we can't define. So after this indeterminate form, we are applying L'Hopital rule. So I write the next step applying L'Hopital rule. So I write the functions, that means this is the after the differentiation. This is after the differentiation. L limit x tends to infinity 2x plus 17 by 4x cube. I write it here. So again I differentiate this. Limit x tends to infinity, differentiation of numerator, differentiate the 2x, 2 into differentiation of x is 1, 2 plus differentiation of 17 is 0, so 2 by 4 into differentiation of x is 3x square, so 4 into 3 12, 12x square. Therefore next the 2 12 cancelled, that means we cancel or otherwise we just apply the limit. X tends to infinity means x equal to infinity, so 2 by 12 infinity square means infinity, 12 into infinity, infinity. So 1 by infinity 0. So 0 is the answer for the given limit. Therefore answer of this limit is 0. Therefore I write it limit x tends to infinity, x square plus 17x plus 29 by x power 4 equal to 0. This is the answer. Next example 7.42. Evaluate limit x tends to 0, not x tends to 0, x tends to infinity, e power x by x power m belongs to n. Here the limit is x tends to infinity. So now you see, so limit x tends to infinity, e power x by x power m belongs to n. So I write the given function. Limit x tends to infinity, e power x by x power m equal to e power infinity is infinity by, that means x power infinity power m is infinity. So infinity by infinity is, this is the indeterminate form. So put x equal to infinity, we get the answer infinity by infinity, indeterminate form. Here infinity will come. Limit x tends to infinity, limit x tends to infinity. So infinity by infinity is indeterminate. So after the indeterminate we are applying L'Hopital rule. So I write the given function, same function, limit x tends to infinity, e power x by x power m, applying L'Hopital rule m times. So L'Hopital rule m times means limit x tends to infinity, e power x, m time means m factorial. So e power x by m factorial. So I substitute x equal to infinity, e power infinity by m factorial. So e power infinity is infinity, infinity by m factorial, infinity by m factorial is infinity. So next example 7.43. So using L'Hopital rule, prove that limit x tends to 0 plus 1 plus x whole power 1 by x equal to e. So the question is, with the L'Hopital rule, we find out the answer. Limit x tends to 0 plus 1 plus x whole power 1 by x equal to e. This result we will prove. So first I write the LHS. The LHS is limit x tends to 0 plus 0 plus means it is the right hand limit, RHS limit. So right limit, it denote the represent the right limit. So limit x tends to 0, right limit x tends to 0, 1 plus x whole power 1 by x. So I take this function as y equal to 1 plus x whole power 1 by x. Let y equal to 1 plus x whole power 1 by x, taking log on both sides. So both the sides I taking the log. So log y equal to log of 1 plus x whole power 1 by x. So this power I write it, it is a multiplication. So I write 1 by x into log of 1 plus x. So in the next step I write log of 1 plus x by x. Therefore log y equal to log of 1 plus x by x. Now both the side I taking the limit. So limit x tends to 0, log y equal to limit x tends to 0, log of 1 plus x by x. So again I substitute x equal to 0. X equal to 0 means here log 1 by 0. Log 1 is 0. So 0 by 0. Again we get the indeterminate form. This is the indeterminate form. So we are applying L'Hopital rule. Therefore limit x tends to 0 plus log y equal to, I write the function, this limit functions. Limit x tends to 0 plus log y equal to limit x tends to 0 plus, that means 1 by 1 plus x by 1. That means I differentiate this. L'Hopital rule means we differentiate these functions. Limit x tends to 0 plus log of 1 plus x. I differentiate the log. Definition of log is 1 by 1 plus x. Next definition of 1 is x is 1. So by denominator I differentiate the denominator. Definition of x is 1. So 1 by 1 plus x by 1. So limit x tends to 0 plus log y equal to limit x tends to 0 plus 1 by 1 plus x. In the next step from this I write limit x tends to 0, log y equal to, I substitute the limit x equal to 0. So 1 by 1. So therefore limit log y x tends to 0, log y equal to 1. So therefore now I taking the exponential on both sides. So exponential of e of log y equal to e power 1. So e exponential and log are cancelled. So y, we get the answer y in the LHS. Therefore limit x tends to 1, y equal to e power 1. So from this is not 1, it is a 0, x tends to 0. So from this I write limit x tends to 0 plus, that means y means y equation is 1 plus x whole power 1 by x is the y. So I substitute this RHS for y. So I write it 1 plus x whole power 1 by x equal to e. After that I substitute the x values, x equal to 0. So this after that not substitute the answer, because this is the required answer, because you see this is our required answer. Limit x tends to 0 plus 1 plus x whole power 1 by x equal to e. So we stop up to this. This result only we needed, so we stop up to this. Okay, so limit x tends to 0 plus 1 plus x whole power 1 by x equal to e. This is our proof. So we proved the required result. So now next we discuss about the example 7.44. Evaluate limit x tends to infinity 1 plus 2x power 1 by 2 log x. So first I write the evaluate means we find out the answer for this limit. So I write the given limit. Limit x tends to infinity 1 plus 2x whole power 1 by 2 log x. So here I consider f of x equal to 1 plus 2x power 1 by 2 log x. The next step I write it taking log on both sides. So both the side I take the log. So log of f of x equal to log of 1 plus 2x whole power 1 by 2 into log x. So after that this power I write in the multiplication. So I write 1 by 2 log x into 1 by 2 log x into log of 1 plus 2x. So that means log of power. So the power in the log means I write the power in the multiplication. So I write it 1 by 2 log x into log of 1 plus 2x. That means I write log of 1 plus 2x by 2 log x. So log of f of x equal to log of 1 plus 2x by 2 log x. So in the next step, now I apply the limit. Here limit is x tends to infinity, so both the side I applying limit x tends to infinity. Limit x tends to infinity, log of f of x equal to limit x tends to infinity log of 1 plus 2x by 2 log x equal to the next step log of 2. Now I apply the limit x tends to infinity means x equal to infinity, so I write it log of 1 plus x. I substitute infinity, 2 into infinity, no cos here, so only 2 into infinity by 2 into log infinity. So log of 1 plus 2 into infinity is infinity, 1 plus infinity is infinity, so log infinity is infinity by, again log infinity value is infinity, so 2 into infinity is infinity, so infinity by infinity. This is our answer for this problem. So this is not answer, this is the indeterminate, we are not consider this type of answer, so this is a, we can't define this, so this is the indeterminate form. So after this, in this indeterminate form, we apply the L'Hopital rule. So again I write the functions, that means limit x tends to infinity log f of x. Before the limit applying I write it, that means limit x tends to infinity log of f of x equal to limit x tends to infinity log of 1 plus 2x by 2 log x. In the next step I write applying L'Hopital rule. So I write it limit x tends to infinity, that means I differentiate the terms. So that means log of 1 plus 2x, I differentiate the log is 1 by 1 plus 2x and differentiate the 1 plus 2x, that means differentiation of 1 is 0 and differentiation of 2x is 2, so into 2 by 2 into differentiation of log x 1 by x. So I write it limit x tends to infinity, that means 2 by 1 plus 2 log 1 plus 2x into 2 by x, I write it x by, I reciprocate it is in the denominator, so 2 by x I write it x by 2, so 2 will limit x tends to infinity, that means 2 by 1 plus 2x into x by, that means 2 by x I write it x by 2, so 2 cancelled, so limit x tends to infinity x by 1 plus 2x. So now I applying the limit x tends to infinity means x equal to infinity, x equal to infinity means I just applying infinity by 1 plus 2 into infinity, so 1 plus infinity is infinity, so infinity by infinity, again it is a indeterminate form. So again we apply L'Hopital rule. So before the limit substitute, that step we take, this is the, here this step we substitute the limit, so this step we take limit x tends to infinity x by 1 plus 2x, this step we take, and again we differentiate the numerator and the denominator. So I write this step. So before this step only we applying the limit, so before step we take the function, so I write it limit x tends to infinity x by 1 plus 2x, applying L'Hopital rule. So now L'Hopital rule means differentiate numerator and denominator, so differentiation of x is 1 by differentiation of denominator is, differentiation of 1 is 0 and 2x, differentiation of 2 into that means 2 is a multiplication, so 2 into differentiation of x is 1, so 1 by 2, so limit x tends to infinity 1 by 2 equal to 1 by 2. So therefore this is the answer for our given limit, that means given limit means limit x tends to infinity, not given limit x tends to, that means limit x tends to infinity log of f of x equal to 1 by 2. So I take the log from the outside, so I write it log of limit x tends to infinity f of x equal to 1 by 2. So next step, so now I taking the exponential on both side, so exponential of e power log is e and log are cancelled, so the LHS I write limit x tends to infinity f of x equal to e power 1 by 2. So the next step, e power 1 by 2 means I represented root e, so therefore limit x tends to infinity f of x equal to root e. F of x means 1 plus 2x whole power 1 by 2 log x, this is the f of x, so therefore limit x tends to infinity 1 plus 2x whole power 1 by 2 log x equal to root e. So we find out the answer. Next problem. So now we discuss about the example 7.45, evaluate limit, say this is a question, not this question, this question is not, no, it is wrong. So evaluate limit x tends to 1, that means x power 1 by x minus 1, this is our question. Evaluate limit x tends to 1, that means x power 1 by x minus 1. Now we find out the answer for this limit. So I write it, this function I take f of x, let f of x equal to x power 1 by x minus 1. So both the side I take the log, so log f of x equal to log of x power 1 by x minus 1. So in the log, the power terms, we multiply the numerator, so we write 1 by x minus 1 in the multiplication. So I write, that means log f of x equal to 1 by x minus 1 into log x. So from this I write it, log of f of x equal to log x by x minus 1. So limit x tends to 1, log f of x equal to, both the side I taking the limit is limit x tends to 1, so limit x tends to 1, log f of x equal to limit x tends to 1 log x by x minus 1. So I applying the limit x equal to 1, so log 1 is 0, 1 minus 1 is 0, so 0 by 0 indeterminate form, applying L'Hopital rule. So L'Hopital rule means we differentiate the numerator and denominator. So this functions, we take this functions and differentiate. So limit x tends to 1, log f of x equal to limit x tends to 1, that means I differentiate the log x. Definition of log x is 1 by x by differentiation of x is 1 minus differentiation of 1 is 0. So which implies limit x tends to 1, log of, that means log f of x equal to limit x tends to 1 by x. So from this I write it, limit x tends to 1, log f of x. So I apply the limit here, x equal to 1, so 1 by 1 is 1, so its answer is 1. Log of f of x equal to 1 means limit x tends to 1, f of x, I substitute the f of x equation, f of x equal to x power 1 by x minus 1. So I substitute limit x tends to 1, x power 1 by x minus 1 equal to e. This is the answer for our given limit. Therefore we find the answer for this, limit x tends to 1, x power 1 by x minus 1 equal to e. We complete the class.